positive direction, and a 5 kilogram object in the positive direction to 6 meters per second. Oh, at the beginning, this was at rest. And then after the collision, this 5 kilogram will move in the positive direction 6 meters per second. The question is, what's the initial speed of this 3 kilogram? The information we know is elastic collision. Okay. So what we know is, what we can use is one, the conservation of the momentum, right? The momentum is at the beginning equal to the momentum in the end. That's the first law we can use. The second one is because it's elastic collision, what do we know from that information? The kinetic energy should be the same, because there is no loss of energy from this elastic collision. So the kinetic at the beginning should be equal to the kinetic after the collision, right? Okay, so from the first one, what we can get is the initial, well, the 3 kilogram times the initial velocity plus 5 kilogram. Initially it was at rest, so it's 0, right? It's equal to after the collision. We don't know the velocity, but we know this 5 kilogram got a velocity of 6 meters per second. Right? That's the momentum at the beginning and then after collision. You understand here, right? Mm-hmm. So that's the first equation we got. The second one is the kinetic energy. 1/2 3 kilogram, the initial velocity square, plus 0, 5 kilogram object was 0. And then 1/2 3 kilogram velocities after the collision plus 5 1/2 times 5 kilogram times 6 meters per second squared. So the initial kinetic energy is equal to the kinetic energy after the collision, right? That will become, and then you need to solve this. Let's write it, simplify these two. The first one will be 3, the initial velocity of this 3 kilogram object, plus 0 is equal to 3, the velocity afterward, plus 30, 5, 6 is 30. And then we can further simplify it. 3 equal to 30, right? Just move this to the left. And then we can divide everything by 3. 3 is equal to 10. Right? From this, we can get this. You understand? Here?
How did we lose the 1/2?
What do you mean? Oh, I mean from this one, the number 1.
Mm-hmm. And then for number 2.
Right now
We
we're
still-
looking at number 1.
Okay, okay.
We are still looking at them. From number 1, we got this.
From the top.
The top. So it's 3 V3 plus 0 equal to 3 prime plus 30. Is this, right?
Right.
And then if we move this to the left, we got 3 times this minus this equal to 30. So if we divide by 3,
Mm-hmm.
we got this. And then from the second one, what we got is let me see, 3/2 times the initial velocity square equal to 3/2 velocity afterward plus that is 3618 times 5. If you calculate, you can get 90. And then if you times 2/3, 2/3, you cancel this, right? Then you got that's 30, 60. So you got this. So from this you simplify everything. And then the question is asking you what the initial speed of the 3 kilogram is V3, right? That's what the question asks you. Because from here we know it's equal to we can just replace here with V3 minus 10. V3 minus 10 squared plus 60, which will be V3 squared minus 20, V3 plus 100 plus 60. Let me see. So we can cancel this, right? V0. Negative 20 V3 plus 160 is 0. V3, 20 V3 is 160. So V3 is equal to 8. Okay.
How did you
So you understand here how we got
Yeah.
1, 2. 1 is the conservation of the momentum, and 2 is the conservation of the kinetic energy. Okay? And the rest thing is just to solve the problem.
it is algebra?
From the first one, we got this the relationship between the initial speed and the speed after the collision. That's what we got from the first one. And from the second one, we got another equation. You just need to replace this variant with this one. And then you will be able to calculate.
I'm just trying to see how you have -20 V3